Hello and welcome there to another episode of the Cliff Notes podcast, where we ask a leader and find their way. Today I've been joined by Vats Vanar, who is the VP of Products and Strategy at KX for business outcomes for IoT driven by Real Time Analytical Insights at the edge. Hey there, Vats. How can I help you today? You've been very gracious of giving us some of your busy time. How have you been doing?
Excellent. Thank you for having me. Grateful to be able to spend some time and talk about manufacturing and what we do in KX and what my passion, IoT.
Could you give us a little bit of a background to yourself before we get into learning more about the company and this sector?
Sure. I'm Vats Vana. I'm VP of Product and Strategy for Industrial IoT in KX. I help manufacturing, automotive, CPG, and telco customers to leverage the power of streaming and real-time distributed analytics to drive business and financial outcomes. I have about 25 plus years of experience across a diverse set of engagements in manufacturing, energy, telecom, and transportation industry. I started my career as an instrumentation and control engineer. I have an electrical engineering background, formal training in electrical engineering, and I did technology management further to orient myself towards the outcomes for customers, business outcomes for customers leveraging the power of technology. I have worked in AI and ML systems, largely on the edge, and I've also worked extensively with other technology providers feeding into major manufacturers such as BF Goodrich, Setpoint, Dow Chemicals, DuPont.
That sounds great. So are you used to working more at these sort of large manufacturing plant spaces, or does it seems from your background that you're also used to interfacing with those customers in a business way as rather than just as a product focus?
Yeah, that's a very good question. I was one of the lucky ones that happened to get experience in erection and commissioning of manufacturing plants from ground zero. Earlier, when I started my career, I was involved in design and project engineering for big petrochemical and refinery facilities. And later came a time to implement those and bring up the plant according to the design. So I worked in erection and commissioning for over 6 years, commissioning huge refineries and petrochemical and captive energy facilities. As part of which, I learned quite a bit working with various pieces of equipment and various process and various, manufacturing practices. The reason why I said I was lucky was that it generally takes about 15, 20 years to get experience across, various types of equipment and various types of manufacturing and various processes, etc. But during erection and commissioning, you have to get it all done within a year or year and a half. So you tend to work in, 12-hour shift within these plants. So that gave me quite a bit of a strong foundation to get my career started in manufacturing.
And is that where the sort of interest in data and availability comes? If you're working a big long shift like that, there isn't a lot of space for downtime. So you need that data when you need it.
That's correct. It's interesting that my career actually took a turn towards above and beyond the manufacturing and instrumentation control automation experience I had during erection and commissioning. Shifted into telecom. So I did work in telecom for over 15 years. Worked with major telco providers here in the United States and globally. And if I were to be reflecting on the career path, and it just so happened in a serendipitous way, if you may, it all has evolved into industrial IoT. If you think about telco providers, their main bread and butter is providing access to where the data is on the edge or wherever it is in the cloud. But from a manufacturer's point of view, there are lots of these sensor control and automation systems. These things came together as what they call as things in the Internet of Things. So the telco guys brought in the Internet, and the things were already up and running in the manufacturer's facility. Combine these two, it became the industrial Internet of Things. And I just happen to have been a beneficiary being in that sweet spot between telco and manufacturing.
Mm-hmm. When we're talking things or the part of IoT, where is that especially for your company?
That's a good question. So KX has been relentlessly involved to provide our customers with fastest and most efficient access to data. The speed is everything. Speed to business value, speed to outcomes is where we work backwards from for our customers. For example, a manufacturer, may want to optimize their facility or increase the capacity of the plant from, let's say, 100,000 tons per annum to 120,000 tons per annum. So that would be more of a business or an operational outcome for the manufacturer, but that's basically where we get started with manufacturers. This is like a bigger goal for a bigger company, but then there can also be smaller outcomes such as how can I make a particular equipment more operationally efficient. So regardless, we tend to work with our customers from a purview of what their business and financial outcomes are and work backwards from there to evolve what insights they should have in order to make the decisions to take actions to drive those outcomes. And the insights usually come from pieces of data. So we have an integrated platform in KX called KX Insights Platform that allows for information to be had from various data sources, and we work on the data, or we allow the customers to work on the data, or right from the point of ingest to transformation and creating insights, and even recommend some actionable decisions for them. So we tend to work with a lot of industries, including in financial services industries, as well as with manufacturers such as automotive, auto body manufacturers, high-speed racing companies like Alpine, as an example. We tend to work with telecom providers for optimizing their radio access networks and enhance customer experience. Bottom line is, in simple words, it's more outcome-driven insights platform in an integrated fashion that can work both on the edge as well as in the cloud for our customers.
Right. So this is a focus not in terms of reporting or management level reports or end of year reports. This is stuff that can be available to engineers or on the factory floor for real-time use.
Exactly. That's a fantastic point you bring up. So many of the current tools and technologies that are available, and it is for a reason, it has its own merit, allows for a certain specific task, such as reporting, to be done in a pretty deep and efficient fashion for, let's say, for a manufacturing customer, as an example. But if you look at the persona and if you look at the orientation of a manufacturing general manager, they're usually fighting fires within the plant to keep the plant up and running. While there are lots of these do-it-yourself tools, such as reporting tools or even database ingest tools or even databases that may be available, whether on the edge or on the cloud, the manufacturers do not have the time to do it themselves. They actually do want an integrated platform that allows them to get closer to their business outcomes so that they can make the decision quickly and get to the outcomes as fast as possible on a daily basis. So that's how we differentiate, by offering an integrated platform. And the part of the platform is certainly a very nice reporting and a dashboarding tool that allows for expedient, not only decisions to be made, but to start with a very fast data ingest, very high performant reporting refreshes on the screens, large volumes of data being able to be loaded into the platform, and a lot of selling points that we have that we bring as part of our integrated analytics platform.
And before we get into what the actual use or the benefits is, what's your feeling as a company that the monitoring and availability has changed in the last few years that has got us to this point that your tool has been improving and being a valuable key?
Yeah, I think to answer your question, which is a good one, it's important to probably take a step backwards to understand where the evolution has been so far from, let's say, a factory perspective or from a shop floor or a manufacturing perspective.
Sponsorship of this podcast has been brought to you by Holding Bay, the digital web agency. Holding Bay specialises in working with B2B companies like manufacturers to build better solutions and drive better sales funnels. So if you would like to build a web application or improve your branding and sales funnel, get in contact today. holdingbay.co.uk or call us on 01273 044 019.
So if you look at some of these manufacturers, or pretty much most, if not all of the manufacturers, they're all up and running. They're mostly automated. They're already producing parts that they're producing, or products that they're producing. They're selling those products. They're making money. They're even nicely profitable. What has changed is thematic convergence of a few technologies that has allowed manufacturers to start thinking about efficiencies more than automation. And those technologies, just to start with, I'd say 4 technologies are influential that are converging that allow for just-in-time, let's say, condition monitoring to a point, to your point. And the most important technology is the access technology. As you know, 5G is proliferating. The adoption is growing. And 5G works very well with vast flow of distributed sensors that can be in the middle of nowhere, that can be within the factory facility, that can be on mobile units, trains, trucks, cars, etc., right? So access is one of the key technologies, and a newer evolution as 5G is enabling higher bandwidth and higher throughput. Secondly, it's smart sensors that are evolving as well. So for example, if you have a pipeline in the middle of nowhere and you want to monitor vibration on a Keystone pipeline, as an example, right, that runs from Canada all the way to Louisiana, right, and you want to monitor the vibration in the oil pipeline every 100 miles or every 50 miles. It's very hard to do the wiring of these sensors and getting the data to where it has to be to make sense. However, there are smart technologies. For example, there's a sensor called Sushi from a company called Yokogawa. It's a Houston-based headquartered company in the US, a Japanese company. There are many such companies that provide smart sensor technologies that allow for sensors to be just plugged in with a magnet, as an example. So this vibration sensor, you can just plop it onto a pipeline. It sort of sticks to the pipeline because there's a magnet attached, and it also has data access, 5G data access, or LoRa data access that allows for vibration data to be made available where it has to be made available. And then third thematic trend is one around what we call as event-driven architectures in IT. This trend is all around microservices, basically breaking down monolithic, huge IT platforms to microservices or smaller applications and networking these applications in publish, subscribe, asynchronous fashion. The adoption of that is spurred by the likes of Kafka, by the likes of MQTT technologies, etc., that allows for data to be made available on a subscription basis versus pulling for data. And it's particularly important because if you have hundreds of millions of sensors in the field, you cannot be asking for what is the next temperature reading, give me the next pressure reading, or the level reading, or the vibration reading, versus making the data available, published to a particular topic, and the consuming IT system, or whatever decision-making system it may be, in this case it could be KX Insights, we would subscribe to certain streams of sensor data that we are interested, that will drive a certain outcome, and we will only consume it when we want to consume it. Or the consumer will consume it only when the consumer wants to consume it. So that's a profound shift in how information is exchanged between various systems. And last but not the least, AI ML technologies and distributed integrated analytical platform technologies like KX has sort of converged with the other three technologies I mentioned and pretty much allowed for what they call as digital transformation to take effect in manufacturing, the part of which is condition monitoring. I'm sorry, a little bit of a long-winded answer there, but I just wanted to set the context of why it is different this time and why it is going to be more meaningful this time.
No, I think that's great. And I think that's a demonstration that it can be a sort of smaller area, or it can be quite a wide distributed area for monitoring. I mean, is that the benefit that this 5G is bringing, that it doesn't have to all be in a Wi-Fi region or cabled into a telephone system?
Exactly. So 5G allows for wireless accessibility, particularly to fleets that are mobile and particularly to areas in the middle of nowhere, if you may, where cellular access is not that readily available. So more and more blanketing of these areas are now possible with the 5G technologies. As a matter of fact, 5G technologies are also coming in via satellites. Like, for example, SpaceX is essentially launching cell phone towers in space. Essentially, these are mobile cell phone towers, nothing but satellites that use 5G technologies underneath them. So more and more coverage certainly and blanketing is certainly happening. But you can imagine 5G will be part of a portfolio of access technologies that the manufacturers will be able to choose from based on their use cases. For example, if they are in a confined control room scenario or in a confined geographic factory facility, they may more than be happy to use Wi-Fi 6, which can equally blanket the entire factory. Or there are other technologies such as wired technologies, such as field bus, that can blanket the entire plant. So it really depends on the use case. And it also really depends on the quote-unquote the depreciation life cycle of the capital investments the manufacturers have already made in wireline technology. When it comes time for replacing those access technologies, certainly 5G would be a serious contender for upgrading those networking technologies.
Mm-hmm. So part of this space is setting up the tracking and the way that this data is coming back into the system. But your system particularly, it taps into that rather than it's part of that system, so that the system may be tracking much more data than necessarily you want to use, or it's tracking other data that's not pertaining to these dashboards. But this can pull the data off. Is that the idea? And then it can analyze it in a more efficient way.
Again, it's a very pertinent and a good segue into how we ingest data. So again, we tend to have always an eye for the manufacturer's financial and business and operational outcomes. It could be something as simple as increased uptime availability of this pump or this compressor or CNC milling machine. So let's take that example, right? So in that particular use case, we sort of tend to determine as to what are the various data points that we require in order to drive that decision, action, and the outcome, which is increasing the uptime for that pump, right? So we would be zooming in on a handful of sensor data from the field that usually we would get via a pub/sub mechanism. In this case, it would be over MQTT, telemetry transport mechanism. It's called message queuing telemetry transport mechanism. It's evolved in factory floor more than 20, 30 years ago. Now it's finding its way into IT and becoming very popular. And the beauty of that protocol, as an example, is that let's say you determine the 5 sensors that you want the data for enhancing it's actually more than 5. So I can give you a number. It's about 16 to 20 data points that we would require to understand the availability profile of an equipment. Bottom line is that we would be subscribing to certain topics where those sensor data would be published from an IoT gateway from the field. And the IoT gateway itself would be integrated into the sensor system in the field through a PLC, as an example. So from our point of view, we are very careful to not ingest the entire volume of data that's available on the equipment versus only ingesting data that we require to drive the particular outcome in mind. So some of these technologies, we are sort of standing on shoulders of, as I said, the event-driven architectures and some of the other converging technologies I mentioned in order to get the data we want to drive those outcomes.
Great. And I think that's given us a good picture. If we could move into maybe if you had some sort of use cases or understanding, say, for a medium-sized manufacturer in the UK, if they're looking to, say, monitor systems and the supply of spare parts and maintenance, is that an application for this process? Or could you give us another example?
Sure. I could give you a couple of examples. So I think first and foremost, we sort of look at the outcome along 4 buckets. So we sort of tend to have these templates, if you may, that we sort of, work along the lines of, right? So a particular use case could be driving cost efficiencies for the manufacturers, or it could be enhancing revenue for the manufacturer, or it could be satisfying a regulatory requirement for the manufacturer, or it could just be a non-negotiable safety and health use case for the manufacturer, right? So we sort of bucket any of these use cases along these 4 categories: revenue drivers, cost drivers, safety and health drivers, and regulatory drivers. If you look at any of the use cases and outcomes, end of the day, it'll always bucket itself into one or more of these categories. So to take the example that you talked about, which is how to optimize for the spare parts before a particular machine breaks, and how to get to the insights to drive to that particular outcome. Where we get started with that is what we call as overall equipment effectiveness, also called as OEE. I think that's one of the fundamental KPI benchmarks that most manufacturers, particularly discrete manufacturers, use in order to optimize for spare parts for a particular machine. That'll obviously be intended to drive the uptime of the machine, right? So just-in-time availability of the spare part means that you can take a shutdown when you want to take the shutdown and quickly replace the part and minimize the downtime, and therefore increase the uptime, right? So that's how that chain works, all the way from spare parts to uptime, if you will. But within the OEE, we tend to track not just the uptime of the machine, which is an important component of the OEE called availability, but we also track the performance of the machine, which has to do with how many parts the machine is manufacturing, right? So a number of these data points that we identify and we start tracking, and we create the calculation for OEE, which is a pretty well understood calculation. The important thing in what we are doing versus what most of the current manufacturers are currently contending with is timely availability of data to drive the OEE in near real time. if not real time. So if you understand the availability and the performance of a particular machine in real time, it means you have a good understanding of the condition or any good and bad condition of the machine. It could be an anomalous condition monitoring, or it could just be healthy condition monitoring as the machine is running in real time. So the time to value that we generate by our platform's ability to monitor for real-time data, movements of the particular 16 to 20 sensors I pointed out that drive the OEE are very important, and our platform seamlessly enables with inbuilt templates that we have called industry accelerators that allows manufacturers to bring in these 16 to 22 data points, plug it into the accelerator. The accelerator code is already pre-built and made ready. Now it's a question of visualization of how the OEE needs to be displayed and everything. We also have screens that we have created for some of our manufacturing customers. A new customer can come in and take and monitor the real-time condition of the machine and therefore predict when the machine will fail with our analytics and therefore manage for spare parts availability in the materials management system and SAP, etc. But that's basically the high level, a template, if you will, that we follow. And we pretty much lower the bar for our manufacturing customers with pre-built accelerators that allow for various outcomes. So that's one of the outcomes that drive the optimization of spare parts. But then there could be others, such as I mentioned earlier, how do you increase the capacity of a particular plant as a whole that has hundreds of equipment, not just one pump or one milling machine or one compressor or one furnace, but let's say it's got hundreds of various pieces of equipment. Now it's a question of orchestrating in real time as to what the availability and the dependencies and the sequential nature of movement of parts between these various pieces of machinery. That requires quite a bit of optimization. So when it comes to optimizing the capacity of a plant from 100 to 120%, as an example, a lot of different data points need to be considered. And we have, various use cases. If you're interested, I don't want to bore you with lots of specific manufacturing jargons, but there are things that we do called overall operational efficiency, OOE, another acronym there. There's something called total effective equipment performance, called TEEP, that we work above and beyond OEE. Then there's statistical process control, there's advanced process control, there's plant-wide optimization, and things like that.
So where's the bit that you're leading to there? Is it the AI of your tool can learn and look for these optimizations? Or is this a consultative function from your company or a training of how to read the information?
That's a good question. That sort of speaks to the strength of our platform, if you may. At a high level, there are several, I'd say 2, 3 or 4 different segments of the platform that are influential in allowing for the insights to be created for a certain outcome in mind. And one of the tools is certainly AI ML tools. The platform is very open. It's got integration into Python, and we have a package called PyKX, which allows customers to bring in their own Python modules and Python packages, allow them to do machine learning training using pre-built notebooks that we have. One of the key mantras that we have in the company is mainly to allow for customers to not DIY, if you may. The manufacturing persona of a GM, as an example, or shift supervisor is very different from an IT persona, which we cater to as well in financial services and telco domains. But when it comes to manufacturing in auto and high-speed racing, etc., outcomes are top of mind. That means time that it takes for the manufacturer to do development, DevOps, deployment, QA has to be minimized by a tenth, if you will. So an order of magnitude faster, time to value is required for them. So one of the key things we do for them is to create pre-built accelerators. We call as industry accelerators and solution accelerators for the various use cases that are common in manufacturing. A bunch of notebooks, machine learning notebooks that are available for manufacturers to pick it up and for their data scientists and application developers to start working on top of it. It goes about 80 to 85% out there. We're not experts in CNC milling machines. We're not experts in compressors or furnaces. But thankfully, we worked with a number of our manufacturing clients that has allowed us to create these template notebooks and template accelerators for them to get started. So these two are 2 pillars, accelerators and notebooks. But then the most important thing is data visibility and real-time availability of data from disparate sources. So we have a very open, neutral, and an interoperable data framework that allows for data to be ingested in real time or in batch mode or in request response mode from various operational systems, business systems, and sensor and control systems. This is usually an unsung hero, if you may, of any good analytics platform. I think one of the main reasons why many IoT programs fail is because of the stumbling block of data not being available in a timely fashion. The manufacturers tend to miss the window just because of the various fragmentation in data silos and various technologies being available in manufacturer. So that data availability has been made seamless with this integrated analytics platform that we have. And last but not the least, there is the streaming analytics function within this analytics platform that allows for making decisions on the data that is in motion, right? It's all about being able to quickly say that certain data stream that's coming in from a sensor or a piece of equipment that's running in the field is going sideways and it's about to fail, and create a predictive maintenance work order in SAP just in time is very meaningful for manufacturers. So all of these four pillars allows for a good analytics platform to get faster time to value, if you will.
Yeah, no, I definitely see that as critical in the companies that we speak to, that they're not looking to add a lot of DevOps or IT staff just to set the stuff up. They want to be able to see the ROI and work through that faster. Just coming into the UK then, have you been working on any initiatives or programs in the UK to further this?
Interestingly enough, we are headquartered in the UK to start with. We work with a lot of customers, Fortune 100 companies. They're in medical equipment, high-speed racing, auto body manufacturers, suppliers that feed into automobile companies, and we also work with major auto companies themselves. But then there is this interesting program that we are very involved in. It's a digital transformation program for smart manufacturing for the UK industry. It's a government-funded program. Essentially, what it is a consortium that is made up of leading companies. These are huge aerospace manufacturers, huge discrete manufacturing companies. There is also academia that is involved that has labs with running machinery. So in other words, if you have a manufacturing facility, a huge manufacturing facility, what are the various piece parts that are required in the solution architecture for a full-fledged manufacturing, and how to make that manufacturing a smart manufacturing facility, and how to take advantage of the four thematic trends that I mentioned earlier, and how to transform the manufacturing by way of getting efficiencies, both from a production point of view as well as from a cost point of view, is what we are showcasing to evolve a couple of data centers. These would be the manufacturing facilities and data centers that showcase the power of timely insights, driving decisions, driving actions that can be taken on real-life running robots, real-life running milling machines, real-life running pumps and compressors, etc. It's a UK-funded program, and therefore it's public, and it will be, soon hit live, just from a point of view of being made available to the public as well as to the various industry partners that want to learn from this program and transform their own operations.
It sounds really interesting. Thanks very much for joining us today. I just wondered whether we could just close out the interview with some more of the sort of fun personal questions. We'd try and get the guests to get a feeling of where they're at and what they're doing.
Sure, absolutely.
So maybe we could start that with, do you have a favorite tool or book that you've been enjoying this year that you might like to recommend to the listeners?
Actually, I have an all-time favorite, but one of the ones that I'm reading, and I'm a little late to the party on this, is called Superintelligence by Nick Bostrom. This has got to do with AI and how the AI technology is evolving toward what they call a singularity. It's partly frightening and it's partly very promising as well. I'm sort of halfway through the book and it's pretty riveting and I can't keep it down. It's one that I would recommend for anybody that's interested, not just for somebody that is in the field of analytics or AI, but above and beyond, because I think the whole lifestyles of people, technologies are going to be augmented with AI technologies, hopefully for the good.
Cool. I'll put that on my list and have a look. And the other fun question we try and end with is if I could give you superpowers, or you can hand this over and give it to one of your customers, what couple of things do you think would come to hand as being useful for your superpowers to get you out of a corner and make you successful in business this year?
That's a good question. Before I attack that one, I just want to throw it out there. I happen to be a space nerd as well, so I follow some of the developments, in LEO technologies, low Earth orbit, satellite technologies, etc. But one of the favorite books that has always been a North Star for me is Hitchhiker's Guide to the Galaxy. Just something I keep reading, going back to again and again. But just from a point of view of what superpowers, if I had, would make our customers more successful, I think above and beyond technology, whether it is data access technologies or data wrangling technologies or even machine learning or an analytics platform, I think above and beyond those, I think the key is one around culture within companies. If there was a way, for me to change the customers to resonate to the possibilities that digital transformation could bring in terms of efficiencies in their business operations, and have the various siloed business and operational groups, particularly what they call as the OT-IT divide in industrial IoT. The process and automation guys have been running factories for years and years, decades and decades, and everything is working. And here come the IT folks with newer technologies and newer frameworks and architectures, trying to create an industrial IoT framework. A lot of times it takes a while for it to take up, if you will, or uptake. If there was a way to expedite that by way of, I guess, quote unquote, infiltrating the culture within the manufacturing industry, I think it goes above and beyond speaking to the right persona and to the right, let's say, ambassador within the customer. If there was a way to do that, I think that would be the first thing I would do, to have them resonate to the possibilities of enhanced financial outcomes for them, both revenues and cost efficiencies.
Mm-hmm. I think that's a really warm sentiment. That's what most of this comes back to, isn't it? It's people and how people can work better with each other. Trends and technology and processes operate in waves of coming through, being successful, and then fading off, and the new thing comes in, but then maybe the old thing comes back again in a new way. But it's still the people who've got to work together and move forward. So I think that's a really great sentiment. So thanks for joining us again today. And I wondered whether you could just summarize what's the sort of good customer or good people who should come and contact you, and where can they get in contact if they'd like to learn more?
They should go to kx.com, and they can also Google for KX CEBR report. And this is an independent research, business, and economic analysis that we happen to have done recently in collaboration with CEBR. So if somebody Googles for KX CEBR report, it's got a lot of nuggets and useful tidbits on the importance of time to value, more than just ingesting data or wrangling data or creating data. Timely outcomes, timely decisions, timely actions are important. So kx.com and Google for KX CEBR report would be the two things top of mind for me.
Thank you again, Vats. And we look forward to speaking to you again soon.
Thanks for the opportunity.
Thanks for joining us again today on the Cliff Notes podcast. If you'd like to get in contact with myself or the guest, you can reach out to us at the website cliffnotespodcast.com, where the show notes and contact details will be available for this show and previous shows. And we always like to hear from you. Thank you, and see you again next time.